Morning children, this is 8th standard Maths Factorisation lesson in part 2. Today let us study the factorization using identities. So children, these are the identities used to factorize the given algebraic expressions. The identities we use are a plus b whole square is equal to a square plus 2ab plus b square. A minus b whole square is equal to a square minus 2ab plus b square. A plus b into a minus b equal to a square minus b square. And the fourth identity, x plus a into x minus b equal to x square plus a plus b into x plus ab. Now, to understand the application of these identities in solving the problems, let us solve exercise 6.2, factorize. Now, what we have to do is consider the first problem. We have a square plus 8a plus 16. Now, we have to compare this given algebraic expression with these identities. Then we have to select which identity will be exact to solve this problem. See, in the first problem, we have three terms, a square, 8a and 16. Now, compare with the identities. The first and the third terms are perfect squares with the positive sign. We know that a square, the coefficient of a square will be 1 and 16 is the perfect square, that is 4. 4 into 4 gives 16, therefore 16 is a perfect square and both have the positive sign before the middle term. So this expression is in the form of the first identity, that is a square plus 2ab plus b square. Therefore the identity is a square plus 2ab plus b square. In the next step, write the a and b values. When compared to the given problem, a will be equal to a, that is 1. The value of the coefficient of a is 1. Then b will be equal to 4. When you do 4 square, it becomes 16. Therefore, the value of b will be equal to 4. Now, write in this form, we have a square plus 2ab plus b square is equal to a, the value is a, so a square plus 2 into a, that is a into b, the value of b is 4 plus b square becomes 4 square. Now simplify, a square plus 2 fours are 8a plus 4 into 4, 16. We got back the original algebraic expression, and this a square plus 8a plus 16 is in the form of a plus b whole square. So now it is in the form of a plus b whole square. In the place of a, we have a plus, in the place of b, we have 4. A plus 4, then whole square, which is the required factorization of the problem a square plus 8a plus 16. Now consider the second problem, in which we have 25m square plus 30m plus 9. We have the three terms. See the first and the third term, 25 and 9, both are perfect squares. 25, we have 5 into 5 becomes 25, and 9, square root of 9 is 3. Therefore, the identity which fits this algebraic expression is a square plus 2ab plus b square. Now, write the values of a. A will be equal to 5m and b will be equal to 3. Therefore, now write a square plus 2ab plus b square is equal to, in the place of a, substitute 5m whole square plus 2 into a value is 5m into b value is 3 plus 3 square. Now 5m whole square, that is 5 square, 5 into 5, 25, m square, m into m, it is m square, plus 2 5s are 10, 10 3s are 30, plus 30m plus 3 into 3, it becomes 9. We got the original algebraic expression. Therefore, in the next step, you write 25m square plus 30m plus 9 is of the form a plus b whole square. So, in the place of a, write it as 5m plus b, it is 3. 5m plus 3 whole square is the required factorization of the problem. 25m square plus 30m plus 9, which is the identity used is a square plus 2ab plus b square, which will be equal to a plus b whole square. Now consider the third problem. We have p square minus 10p plus 25. So there are three terms, and the first and the third term both are squares, perfect squares, and the second term is with negative sign. Therefore, the expression is of the form second identity, that is a minus b whole square is equal to a square minus 2ab plus b square. And hence, this expression is in the form of a square minus 2ab plus b square. Now, substitute the values. A will be equal to p. Then, b will be equal to square root of 25 is 5. Now, write a square minus 2ab plus b square. That will be equal to, now, a square is p square minus 2 into the value of a is p into value of b is 5 plus b square, it is 5 square. When you simplify, we will get p square minus 5 2s are 10p plus 5 5s are 25. We got back the original expression. Therefore, p square minus 10p plus 25 is in the form of a minus b whole square. Since we have a square minus 2ab plus b square is equal to a minus b whole square has the formula. Therefore, p square minus 10p plus 25 will be equal to, the value of a is p minus the value of b is 5. Therefore, p minus 5 whole square is the required factorization of this problem. Now consider the fourth problem. 121b square minus 88bc plus 16c square. Both are perfect squares, the first and the third term. 121, the square root of 121 is 11 and the square root of 16 is 4. Therefore, both are perfect squares and the middle term 88bc has the negative sign. Therefore, the identity used in this problem is a square minus 2ab plus b square. Now, substitute the values. A will be equal to, since it is 121b square, it is 11b. Then b will be equal to, square root of 16 is 4 and c, 4c. Now, substitute a square minus 2ab plus b square is equal to, a, it is 11b, so 11b whole square minus 2 into the value of a is 11b into the value of b is 4c. Either you can use the multiplication symbol or you can apply the bracket. Both denotes the multiplication, plus b square, it is 4c whole square. On further simplification, 11b whole square. So 11 into 11, you will get 121 b square minus 11 twos are 22 and 22 into 4 you get back 88 BC plus 4c whole square is 4 fours are 16c square. We got back the original expression. Therefore 121 b square minus 88 bc plus 16c square is of the form a minus b whole square. Therefore, in the place of a, we will substitute 11b minus b, we have 4c whole square. Therefore, in the given problem, 11b minus 4c whole square is the required factorization of this problem. Now consider the fifth problem in which we have 4p square minus 9q square. And this algebraic expression, we have two terms. The first term and the second term both are perfect squares and they have the negative sign. Therefore, the identity which suits is a square minus b square, and hence this expression is in the form of a square minus b square. Now substitute the values where a is equal to 2p and b will be equal to square root of 9 is 3q. Now take the formula. A square minus b square is equal to, in the place of a we have 2p whole square minus, in the place of b we have 3q whole square, which is of the form a plus b into a minus b. Therefore, we shall write this expression in the form of a plus b into a minus b. We have a has 2p plus b has 3q. Therefore, this is a plus b into a minus b. The value of a is 2p minus the value of b is 3q. Therefore, the required factorization of this problem will be equal to 2p plus 3q into 2p minus 3q. Since this problem is in the form of the identity a square minus b square, which is equal to a plus b into a minus b. Next problem, 16x to the power 5 minus 144x to the power 3. Since in this problem we do not have any identity that can be used in this problem, let us take a common factor. We know that the variable we can take common in the two terms will be x, and that will be x cube. Consider the numerical values 16 and 44. Both are divisible by the number 16. Therefore, take 16 as a common factor. Then out of x to the power 5 and x to the power 3, take x to the power 3 as a common factor. Then 16 is taken out as a common factor. Then we have x to the power 5. Out of x to the power 5, the x to the power 3 has been taken out and the remaining is x square minus 16 is a common factor and 144. We know that 16 nines are 144. Therefore, 9x cube is taken out as a common factor. Now, in the next step, 16x cube into, now consider x square minus 9. Both are perfect squares with a negative sign. Therefore, it fits the identity a square minus b square will be equal to a plus b into a minus b. Therefore, we shall first write in the form of a square minus b square. That will be x square, a square minus b square. The value of b will be 3. Square root of 9 is 3. So 3 square. So in the next step, when you further simplify, 16x cube into a square minus b square is in the form of a plus b into a minus b. Therefore, it will be x plus 3 into x minus 3. Therefore, 16x cube into x plus 3 into x minus 3 is the required factorization of this problem. Now consider the next problem in which we have 2x cube plus 2xy square plus 2xz whole square. So in this expression, we do not have any identity that can be used in this problem. But we can take a common factor in this expression. The common factor is 2. Then we have x in 3 terms. We can take x as common out of x cube, x and x. We can take x as a common factor. And the remaining value inside the bracket will be equal to 2 we had already taken out. Out of x cube, x has been taken out. And the remaining will be x square plus 2x is removed. Then we have y square plus 2x has been removed, then we have z square. Therefore, the required factorization by using the common factor will be equal to 2x into x square plus y square plus z square.